Welcome you in the second lecture on control system engineering. Today we'll discuss open and closed loop control systems. Where in the first lecture we discussed the basic structure of a control system. Now, as you know, the simplistic form of the block diagram of a control system is we have a control system, we have some input to it, and we have an output. This is the simplistic form of block diagram of a control system. As I said, any control system takes an input to generate an output. This is what we discussed in the previous lecture. As for example, in that case of the example of an elevator, if we wish to move from ground floor of a building, say for example, we have this as of a tall building, this is the ground floor, and this is, say for example, first, second, third, fourth, and fifth. We want to reach to the fifth floor, and this is, say for example, the elevator. This is the fifth floor. So what I said that time was that once we enter the elevator, we press button 5. So pressing of the button is the input or the reference input, and eventually when the lift moves up, we reach the fifth floor, and that's the desired output. So in general, as I said, it takes an input and produces an output, which is also called as the desired output. This input is also called as the reference input. Now this block so far is concerned, this control system so far is concerned, we can split this block into two blocks. One block and then followed by another block. So we are splitting this into two blocks. So the first block is the controller, and the second block is the process. So we have a reference input and we have the output, which is also sometimes called as the desired output. So this controller so far is concerned, it will control the amount of input, and the controlled input will be processed here by the processor so as to achieve a desired output. Now, so far as these control systems, the ones that I have drawn are concerned, let me draw it again. We have this as a control unit and then a process. We have an input, we have an output. This is our controller, this is the process. If we look at these block diagrams, we see we are providing some input, we achieve an output, but there is no feedback from the output to the input. No feedback from the output to the input. What does that mean? That means if we intend to reach to the fifth floor, for example, in case of the example of an elevator, we want to reach to the fifth floor, we actually reach some level which will be very close to the fifth floor, slightly up or down, or even in certain cases we may not be exactly able to reach the fifth floor. But does this input know about it? The input in such circumstances, under this circumstance or under this situation, has no knowledge of whether the output has been actually reached or not. Let me take few examples to understand this point, to make you understand this point. And such systems are called as non-feedback systems, non-feedback or open loop systems. So this basically represents an open loop control system. The second one, without this line, without this also is an example of an also is an example, rather not an example, is a representation of an open loop system, non-feedback or non-feedback systems. Now let me explain it what I mean by open loop systems. Let us take an example of an immersion rod or immersion water heater. Examples of open loop systems. Before coming to the definition, we'll first take a few examples of open loop systems and then we'll come to the definition. So, open loop systems. As I said, the first example would be that of an immersion water heater. Immersion water heater. Say for example, we have water in some bucket and we use an immersion rod for heating it. So an immersion rod basically is a metallic coil used for heating water. So we have water inside the bucket. This is bucket full of water and we have an immersion rod. Immersion rod. So when we turn on the switch of the immersion rod, the water continues to boil, continues to heat, and eventually it starts boiling. There is no mechanism by which the system gets to know that the water has become hot and it should stop heating. So there is unnecessarily wastage of energy, even though the water is boiling, but the system doesn't know that it should stop. So such a system is an example of an open loop system, as the input has no knowledge of the output and it continues to provide input to the system, and the system continues, the rod continues to boil the water within the bucket. Another example could be an ordinary electric iron. Ordinary electric iron used for ironing the clothes. What happens in an ordinary iron is that when we turn on the switch of an electric iron, its temperature continues to rise. The temperature continues to rise. It may even burn the clothes. So because the input doesn't know what is the output temperature, or that the temperature has been achieved, which would be the temperature that would be suitable for ironing the clothes has been achieved. But what happens in an ordinary iron is that the moment we turn on the switch, it continues to heat and it may even result in burning of the clothes. The input, for example, in both the cases, be it an electric iron or be it the immersion rod, is an electric signal. The primary reason in both these cases, the primary motivation in both the cases is to produce heating, or the temperature rise is the desired output. But because there is no feedback from the output to the input never stops. It continues to provide electric energy to the system, which is not a very good option. So the input to the controller in an open loop system, the input is totally independent of output. Is totally independent of output of the system. So that in other words means there is no feedback signal from the output to the input in order to achieve the desired output. Now let us take some advantages of open loop systems. Advantages of open loop systems. Or before coming to the advantages, let's now define an open loop system first. Definition. So, an open loop system, an open loop system is a control system, in which the output of the system depends on the input. But the input to the controller is independent of the output of this system. So that in other words means there is no feedback. So there is no feedback from output side to input side. So if we can again look at this diagram, this block diagram, we can say that in an open loop control system, a reference input is given to the system in order to get the desired output. But the output is not considered for further necessary action. That means there is no connection from the output side to the input side. This link is missing from output side to input side. So that's what an open loop system means. Now let's take few examples, rather advantages of open loop systems. Advantages of open loop systems. So they are simple to construct, simple in construction. As we don't need a feedback from the output to the input side, that's we don't need any sensors, etc. In case of feeding the signal back, we need some sensors. The sensors will monitor the output minutely. At every instant of time, these sensors measure the output. But since we don't have a closed loop system, we have an open loop system, so we are not monitoring the output. As I said, for example, in case of the iron rod, the immersion rod, the temperature of the water keeps on going up, but there is no mechanism, rather there are no sensors on the output side so that it can be sensed that the temperature has been achieved and the system will stop providing input. So this is one of the advantages, that it is simple in construction. So naturally, when it is simple in construction, that would mean it's economical. So it will be economic, it will be cheap, as the circuitry is simple. And another advantage would be that it is convenient to use, especially under situations where it is difficult to measure the output. So in case of open loop systems, we don't need to measure the output. So that way it is convenient for using an open loop system, especially as I said under situations where it is difficult to measure the output. Say for example we are to measure the temperature within a furnace, and naturally it will be difficult for us to put sensors within the furnace. But since in an open loop system there is no concern of measuring the output, so it is very convenient to use. Of course, there are certain disadvantages because with convenience comes disadvantages. So there are certain disadvantages of these open loop systems. So the first thing is that it cannot handle disturbances. Cannot handle disturbances. For a disturbance, for example, would mean a voltage fluctuation. For example, if there is a voltage fluctuation in case of an open loop system, the system doesn't respond to that disturbance, so it cannot handle disturbances. So when it cannot handle disturbances, that would mean it is not reliable. These systems, open loop systems, they are not reliable. So in order to account for these disadvantages, we have another configuration called as the closed loop configuration. Loop closed loop configuration. Closed loop configuration or closed loop control system. Closed loop control system. So that's what it is, and how is it different from an open loop control system. So in an open loop control system we have a controller, and then we have a process unit, we have a controller, we have a process unit, we have an output, and we have an input. So this is true both for open and closed loop systems, this part of the diagram, this part of the block diagram. So this is true for an open loop control system. Now in a closed loop control system, what we do is that we feed back the output to the input. So what we do is that the output is being fed back to the input. We have something called as a summing point or an error unit. This unit is called as an error unit or a summing point. This is also called as a summing point, or in general an error unit. So then this is being fed to the controller. Basically this here is called as error. So what is being done in a closed loop system? This is the feedback path from output to the input, so that input knows what's to be done. Rather, the controller gets to know what's to be done. Shall we stop or shall we continue? For example, in case of heating. So as I said, in case of a closed loop system, the output is being monitored continuously. This is being monitored or measured continuously, and then fed back to the input. So what happens, say for example, in case of an example of a lift or an elevator, the input is that we press button 5 as we intend to reach the 5th floor. The lift continues to move up. Say for example, at some point of time it is at 4th floor. So this signal is being fed back to the input. It generates an error. This is basically the error signal is the difference of the two. So the difference would be 1. So when the controller comes to know, when the signal 1 reaches the controller, it gets to know the lift has not reached the 5th floor. So the controller continues to work till the lift reaches fifth floor. When the lift reaches fifth floor, this 5 value is being fed back to the input side at this error unit. When it is being fed back, the difference of the two in this case would be 0. So the error is 0. So the controller gets to know that the lift has reached the desired output and it stops working. So the lift stops at fifth floor. So it is because of this feedback, the controller gets to know whether it has to stop or continue moving upwards so that a desired output is reached. In case of heating, for example, in case of a geyser, if we set the temperature, say for example, to 70 degrees centigrade, let me use a different color. Say for example, we intend to set the temperature to 70 degrees centigrade in case of a geyser. So what happens in case of an electrical geyser? The controller will continue heating, will continuously send a signal to the processor. The processor will continue heating the water within the geyser. Say for example, at some point of time the temperature has reached 50 degrees centigrade. So this 50 degrees centigrade temperature, which is being monitored continuously, is being fed back to the input through this feedback path. The difference between the two, 70 is the input or the reference input, minus 50 would be 20. So an error is generated. The controller continues to work. The processor continues to heat the water within the geyser so that the temperature rises. Eventually a time will come when the temperature reaches to the desired value, that is the 70 degrees centigrade. When it reaches 70 degrees centigrade, this 70 degrees is again fed back to the input. Since the input here, the reference input is 70 degrees centigrade, the desired temperature again is 70 degrees centigrade. The difference or the error in this case would be 0. So the controller stops working. It sends a signal to the processor that there is no more heating required and the temperature within the geyser settles at the value of 70 degrees centigrade. So this is typically a closed loop control system wherein output is being fed back to the system so that it achieves the desired output. Now examples of closed loop systems. Examples of closed loop systems. An air conditioner. Air conditioner is an example of a closed loop system. When the desired temperature, say for example, when the desired temperature is reached, it stops working. In summers, for example, if the door of the room is kept open for some time, so the temperature of the room increases. The temperature of the room increases and the air conditioner automatically turns on to cool down the room temperature to the desired temperature. As I already said, a water geyser is an example. A water geyser is an example of a closed loop control system. What happens is that when the temperature of the geyser is set to some value, the temperature of the water within the geyser continues to rise till it reaches that desired value. This temperature rise is being continuously monitored. By sensors within the geyser. When the desired temperature reaches, the geyser automatically turns off. The geyser turns off at the desired temperature. Which is being already set. If after usage of some water, the temperature of the water would fall down, what happens is that the geyser again turns on automatically because the sensor senses that the temperature has dropped, so it automatically turns on, thereby resulting once again in heating of the water, and again stops when the desired temperature is reached. So these were some of the examples of open and closed loop control systems. So in a nutshell, we have discussed open and closed loop control systems. We have given few examples of open and closed loop systems. We have been able to understand one point, that in case of open loop systems there is no feedback path from the output to the input side, whereas in case of closed loop control systems there is a feedback path from output to the input side. In our next lecture we'll discuss more generic form of the block diagram of the control systems. So this will do for today. Thank you.